1927. A young physicist sits down to solve a problem nobody had cracked. How does an atom actually emit a flash of light? And how does it absorb one? For decades, physicists had carried two pictures of light that refused to agree with each other. Sometimes light behaved like a wave. It spread out, it bent around corners, it interfered with itself, the way ripples do when they cross on water. And sometimes light behaved like a stream of particles, arriving one at a time, landing in a single spot, countable. Both pictures worked, neither picture worked alone, and nobody had a single framework that could hold both at once, without contradiction. His name was Paul Dirac, and his answer quietly changed what physicists believed was fundamental. Not particles first and fields second, the other way around. Dirac took the electromagnetic field, the same field Faraday and Maxwell had already mapped in the 1800s, and he treated the field itself as the fundamental thing. Then he did something that sounds almost strange when you say it plainly. He applied the mathematics of quantum mechanics to the field, not to a particle moving through the field, to the field. And what fell out of the mathematics was the photon. Not as an assumption, not put in by hand. The photon emerged on its own as a quantized excitation, a discrete, countable ripple in something that was already there, filling space, everywhere, all the time. Wave and particle stopped being a contradiction. They became two ways of describing the same underlying field, depending on which question you asked of it. The wave is what the field does. The particle is what the field's excitation looks like when you count them. Dirac introduced what became known as quantum electrodynamics. Many historians treat this 1927 paper as one of the foundational moments in the birth of quantum field theory. Worth naming one more name here. A physicist called Pascual Jordan was doing closely related work in the same years on the same mathematical machinery. Some historians argue he has never received enough credit for it. Discovery rarely happens with just one name attached. Now, here is where this becomes genuinely strange. A year after the radiation paper, in 1928, Dirac wrote down another equation. This one described the electron, correctly, at speeds close to the speed of light. The equation worked beautifully. But it had a problem. It produced solutions that seemed to describe particles with negative energy. Physicists had no idea what that could possibly mean. Most assumed it was a mathematical artifact, a ghost in the algebra, something to be explained away. Dirac trusted mathematics. In 1931, he proposed something almost nobody wanted to say out loud, that those solutions described a real particle, a particle exactly as heavy as the electron, with exactly the opposite charge, an anti-electron. Nothing like it had ever been observed. 1 year later, 1932, an American physicist named Carl Anderson is photographing cosmic rays in a cloud chamber. He notices particles curving the wrong way in his magnetic field, positively charged, but far too light to be a proton. He had found Dirac's particle. Today, we call it the positron. Sit with the order of events there. The mathematics of the field came first. The particles showed up afterwards, in the real world, to match it. That is not how most people imagine physics works. And it happened again, decades later, on a much larger stage. 6 years after the radiation paper, Dirac shared a Nobel Prize with Schrödinger. The citation was for new productive forms of atomic theory, broadly, for the equation and the relativistic picture of the electron, not specifically for the 1927 paper we started with. Two different achievements, worth keeping distinct. Here is one consequence of the field's first picture that almost nobody mentions. Every electron in the universe is identical, not similar, not manufactured to the same specification, identical, same mass, same charge, same spin, every single one, everywhere. with no exceptions ever found. If electrons were tiny objects, tiny things, this would be an extraordinary coincidence. Why would trillions of separately existing objects match so perfectly? But in the field picture, the question dissolves. There is one electron field. It fills all of space. And every electron you have ever encountered, in your body, in a star, in this screen, is an excitation of that same single field. They are identical for the same reason two ripples on one pond are made of the same water. So, fields are the fundamental layer. Particles are their quantized excitations. For a long time, this stayed elegant mathematics. Powerful, predictive, but hard to point at. No experiment could reach out and touch a field directly. That changed in 2012. Here is why it mattered. In the equations of particle physics, particles like the electron should have no mass at all. They should be racing around at the speed of light, the way photons do. Obviously, they do not. Something was giving them mass. Something, the equations, needed, but that nobody had ever directly detected. The answer proposed, decades earlier, was another field. A field filling all of space. Certain particles interact with it, and that interaction slows them. The way you feel resistance wading through water. That resistance, in this picture, is what mass actually is. An elegant idea. And, for almost 50 years, an undetected one. Because if the field is real, it must have an excitation, its own particle, a ripple. Find that ripple, and you have powerful evidence the field beneath it is really there, and not just a convenient piece of mathematics. On the 4th of July, 2012, two enormous experiments at CERN, ATLAS, and CMS, working independently, announced the same result. A new particle, mass around 125 times that of a proton. The Higgs boson. It is not just another entry on a list of particles. It is the excitation of an entire field, the Higgs field, theorized to fill every point in space, giving fundamental particles, quarks, electrons, their mass, the building blocks that everything else is made from. Again, the field came first in the mathematics, and the particle arrived afterwards to confirm it. The theorists behind the prediction, François Englert and Peter Higgs, received the Nobel the following year. For the theory, not for running the experiment. Different roles, worth telling apart. Now, one honest caveat. Physicists do not all agree on what a field ultimately is. Some regard fields as the actual furniture of reality, the stuff the universe is made of. Others treat them as extraordinarily successful mathematical bookkeeping and remain agnostic about what, exactly, is doing the rippling. That argument is live and unfinished among people who study this for a living. What is not in dispute is the structure. Whatever fields are, they are more fundamental than the particles we once thought were the ground floor. Even physicists admit fields are hard to picture. A comment surfaced under a popular physics video not long ago, a viewer with decades in a scientific career, admitting he simply cannot make field feel as real as particle does. That is not a failure of intelligence. Particles feel like things. Fields feel like empty. Mathematics. But according to the physics itself, that intuition is backwards. The field was always there. The particle is the event. Now here is where this gets interesting. Roughly 2,300 years before Dirac's paper, a tradition of Chinese texts had already described something with a strikingly similar shape. The Tao Te Ching, traditionally linked to a sage named Lao Tzu, though most scholars now date the text itself to around the 4th century before the Common Era. Even its authorship is debated. Chapter 42 lays out a sequence. The Tao gives rise to the One to two, two to three, and three to the 10,000 things. The 10,000 things, That is the traditional Chinese way of saying everything, every distinct object, every separate being, the whole visible world. Notice the direction of that sequence. It does not begin with the many things and ask what they are built from. It begins with one continuous source and describes multiplicity emerging out of it. The many are not the starting point. They are what the one looks like after it has expressed itself. A related text makes the same shape almost tangible. The Zhuangzi, 4th century before the Common Era, or thereabouts. In its 2nd chapter, a teacher describes something called the Great Clod, breathing out. That breath is given a name. The name is wind. When the wind rises, it moves through what the text calls the 10,000 hollows, openings in rocks, cavities in ancient trees, shaped, the text says, like noses, like mouths, like ears, like cups. And each hollow, because of its own particular shape, cries out a completely different note. Some roar like waves, some whistle like arrows, some gasp, some moan. One breath, 10,000 distinct voices. Then the text asks a question directly. Who does the sounding? Not each hollow by itself. The hollow contributes only its shape, not the wind by itself either. Passing through nothing, it makes no sound at all. One continuous breath, appearing as many separate voices, depending entirely on what it moves through. Two completely different investigations, one mathematical, one contemplative, both landing on the same basic shape. The many separate-looking things are not the ground floor. They are what something more continuous looks like, once it shows up as an event, through a particular shape. Now, let me be precise about what this is and what it is not. Chapter 42 is not a physics text. It continues directly into observations about yin and yang, about harmony, about humility. It was never trying to predict quantum field theory. The Zhuangzi is not a physics text either. Its passage about the hollows is aimed at something else entirely, at the way different people, differently shaped by temperament, argue past each other, each certain they alone are right. There is no evidence that Dirac or Jordan or anyone working on the Higgs mechanism ever engaged either text. That connection is not being claimed here. And there is a deeper limit worth naming. The Tao in this cosmology is not one specific field among others. It is described as the source of everything. That is a far larger claim than any single quantum field makes about itself. A physicist would say the electron field is one field, sitting alongside the photon field, the quark fields, and the rest. The Tao Te Ching is not describing one field among many. So the parallel being drawn here is narrow, and it is structural, nothing more. Both frameworks decline to treat the many separate things as the deepest layer available. That is the entire claim. Worth testing this directly, for a moment, not as belief, as something to actually notice. Notice your own breath right now. Coming in, going out, one continuous thing. Now shape it with your throat, your tongue, your lips. It becomes a word. Change the shape, and it becomes a different word entirely. But it was one breath. The shapes only decided how it would show up. Now look at something solid near you. A table, a wall, your own hand. In the field picture, none of that is empty, and none of it is truly separate from the fields filling the space around it. What you are calling the object is a stable pattern, an excitation holding its shape in something far more continuous than it appears. The solidity is completely real at its own level. Your hand will not pass through the table. It is simply not the deepest layer available. In 1927, a physicist changed what counted as fundamental. He treated the field as the real thing, and let the particle emerge from it. In 1932, a particle nobody had ever seen appeared in a cloud chamber, exactly as his mathematics demanded. In 2012, an experiment found the excitation that gave the whole picture its most dramatic evidence yet. 23 centuries before any of them, one text described the many things emerging from the one, and another described a single breath taking on 10,000 different voices, depending on nothing but the shape it passed through. Different tools, different centuries, different questions. Entirely. The same strange shape showing up twice. Ancient wisdom, quantum mystery, direct knowing, this is quantum gnosis.